Hello friends, what's up? Welcome to PCMB tutorial. This is your chemistry class. If you are new to the channel, then I will suggest you guys please watch our introductory video and do like, share and subscribe our channel, and don't forget to tap the bell icon for further updates. Since our subject is chemistry, so I guess this PPT mode will be the best way to explain the topics to you guys. You can feel free to pause the video at any time and take down the notes of what I say. But please don't take screenshots because unless you write down the concepts, the topics won't be clear. So watch the video till the end and take down whatever is necessary. So our first chapter, what you see is matter. If you check the NCERT science book for class 9, the first chapter itself is matter in our surroundings. I find this chapter to be the base of chemistry. At least if you follow this video once, many things will be clear to you. I will not go into the details, but will cover some of the key concepts in a gist. This is the part 1 of the chapter, which is composition of matter. So the topics I'll cover today are what is matter, nature of matter, particles of matter, and characteristics of the particles of matter. So chemistry is a branch of science concerned with the study of matter. It deals with the structure and composition of matter and with the changes that matter undergoes. Besides life, matter and energy are regarded as the two fundamental entities with which the whole universe is composed of. We see a number of things around us. These includes books, pens, water, rocks, minerals, plants, animals, etc. We also notice innumerable substances in our daily lives: the food we eat, the clothes we wear, the paper on which we write, the chair on which we sit, etc. etc. In other words, the actual world around us, consisting of things, is recognized as the material world, and in science we study about matter in this material world. So from this explanation, I hope it is clear what is this matter we are talking about. Thus, matter is defined as anything which has mass, occupies space, and may be perceived by our senses. An important thing to note: when I say may be perceived by our senses, it doesn't mean that everything that we perceive by our senses is matter. Phenomena like heat, light, electricity, magnetism, and sound neither have mass nor do they occupy any space, but can be perceived by our senses. Hence, they are not considered as matter but are considered as forms of energies, that is, they have the capacity to do work. Thus, energy is defined as the capacity to do work. Now moving on to the next topic, which is nature of matter. Ancient philosophers had different beliefs about the nature of matter. Thales suggested that all things arose from water. The Greek philosophers believed that the primary building blocks of all forms of matter were fire, water, air and earth. But an Indian philosopher, Maharishi Kanad, was perhaps the first to suggest that all forms of matter are composed of very small tiny particles known as anu, and that each anu was made up of still smaller particles called paramanu. Later Greek thinker Democritus called these tiny particles as atoms from the Greek word atomos, meaning which cannot be cut. Thus matter is composed of tiny indivisible particles known as atoms. These atoms does not exist in free state. Hence they combine to form molecules to exist independently in nature. So these atoms, molecules are the particles of matter. These particles are so small that it is difficult to see them even with a high-powered microscope. So by applying our common sense, we can guess that there are millions of such particles in matter. From the example, we can see that it is estimated that one drop of water contains about 10 to the power 21 particles of water, and 1 gram of hydrogen contains 6.023 into 10 to the power 23 particles of hydrogen in it. This 6.023 into 10 to the power 23 is known as Avogadro's number, and we will discuss in detail in the chapter mole concept. Now moving on to our next slide, we get particles of matter. Two of the most important particles of matter are atoms and molecules, which I have already discussed in the previous slide. But there is one more, that is iron. Every substance is made up of some constituent particles, and the characteristic properties of the constituent particles determines the characteristic properties of the substance. An atom is the smallest particle of an element that can take part in a chemical reaction. It may or may not exist in free state. A molecule is the smallest particle capable of existing in free state. The molecules of a substance exhibit all the properties of that substance. A molecule is composed of one or more than one kind of atoms. Now let's talk about ion. In the chapter Atomic Structure, we will learn that atoms consist of negatively charged subatomic elementary particles known as electrons. Due to the loss or gain of electrons, the atoms gets electrically charged. This electrically charged atom is known as ion. But sometimes electrically charged group of atoms can also form an ion. There are basically two types of ions. The one which is positively charged known as cations, and the one which is negatively charged known as anions. Let us come back to matter now. What are the characteristics of particles of matter? Point number 1. Particles of matters are very small. To understand this, look at the experiment on the slide. Take 2 to 3 crystals of potassium permanganate, which is KMnO4, and dissolve them in 100 ml of pure water in a beaker. Take 3 other beakers, each filled with 90 ml of pure water. Now take approximately 10 ml of the solution from beaker 1 and put it in beaker 2. Then take out 10 ml of the solution from beaker 2 and put it in beaker 3 and repeat the process till beaker 4 is filled. Now interestingly, we observe that the solutions held in all the beakers are colored, though the color gets fainter and fainter with successive dilution. Thus we come to a conclusion that a small crystal of potassium permanganate contains a very large number of small particles, such that even the smallest particle shows the properties of the parent substance. Point number 2. Particles of matter have interparticle space between them. To understand this, let's consider another experiment. Add 20 gram of common salt, which is sodium chloride, to 100 ml of water in a beaker and mark the level. Dissolve the salt in water by stirring the water with a glass rod. When all the salt has dissolved, we get a solution. It is noticed that even after dissolving 20 gram of salt in 100 ml of water, the volume of water present in the beaker does not increase. This shows that the particles of water are loose and have interparticle space, which has accommodated the dissolved salt particles. This space in between the particles is called interparticle space or intermolecular space. Point number 3. Particles of matter are in constant random motion. Now Brownian motion and diffusion are the best examples to prove it. In class 12 there is a chapter called surface chemistry, where we will learn that Brownian motion is a property of colloidal solutions. But for the time being, we just need to understand that the constant random motion due to which particles of matter constantly collide with each other is called Brownian motion. For example, when we drop a few pollen grains on the surface of water, we observe that the pollen grains move on the surface of water in a rapid zigzag motion. This phenomena was first noticed by Robert Brown, and so it is called Brownian motion. Also, when a beam of sunlight enters a room, tiny dust particles are seen suspended in air, which also move in the same manner and hence undergoes Brownian motion. The next we come to diffusion. The spreading out and mixing of a substance with another substance due to the motion of its particles is called diffusion. Diffusion goes on till an uniform mixture is formed. Now a very important concept lies here. Diffusion is fastest in the cases of gas and slowest in the case of solid. It is because in gases the particles are in constant rapid motion. So we conclude that the rate of diffusion decreases with the increase in density and increases with the increase in temperature. This is Graham's law of diffusion, which we will learn in class 11 in the chapter states of matter. Now let us take an example of diffusion. If we take a gas jar full of bromine vapor, which is reddish brown in color, and invert another gas jar over it filled with air, after some time we observe that the reddish brown bromine vapors spread out into the upper gas jar containing air. This mixing is due to diffusion. So last but not the least, point number 4. Particles of matter attract each other. Particles of matter have a force acting between them. This force keeps the particles together. It is very easy to break pieces of chalk into particles, but not in the case of coal or an iron nail. Thus, this force of attraction varies from substance to substance. The force of attraction between the constituent particles of any form of matter is called the interparticle force or the intermolecular force. The force of attraction between particles of same substance is known as force of cohesion. The cohesive force is different for different kinds of particles. Now, if the particles are not of the same substance, that is, force of attraction acts between particles of different substances, then it is known as force of adhesion. It is the attractive force between molecules of different types of substances. The force of attraction between glass and water is the force of adhesion. Because of this, when it rains, we often see the raindrops cling to window panes. So that's it for today. See you again in the next video. Thanks for watching.